Hello, welcome to Cloud Native Live, where we dive into the code behind Cloud Native. My name is Whitney Lee. I'm a CNCF ambassador, and I'm a developer advocate at VMware Tanzu. Every week on Cloud Native Live, we bring you a new set of presenters to showcase how to work with cloud native technologies. We'll build things, we'll break things, and we'll answer your questions. This week, we have Nick Vermandy with us here to talk about intent-based access control at scale with eBPF and maybe just BPF and traffic pattern detection. Which one?
Yeah, it's BPF. It's not eBPF. It's just a
I just
teaser.
threw the E in there. That was.
It's like having a nail when when the only tool you have is a hammer. Every problem looks like a nail. So this is why I put BPF. But we're gonna talk about it later. But yeah, it's CBPF.
I'm intrigued already. I'm so excited. So this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct. That basically means just be kind to each other, please, and to me and to Nick, please, even though he's using just BPF. I'm kidding. I'm really excited to hear more. Friends who are joining us live, please say hello in the chat and say where you're visiting from. I love how we're a part of a global community. I think it's the coolest thing ever. And as you have questions as we're going, please put them in the chat and we'll answer them for you. And with that, I'll hand it over to Nick Vermandy to kick off today's presentation. Will you introduce yourself, please, Nick?
Yeah, sure. So hi, everyone. I'm Nick Vermandy. I'm the head of DevRel at Authorize. I've been there for a couple of months now. Before that, I've been working for various startups in the cloud native community. Before that, I was at Cisco for also a long time, working on the CNI. And before that, I had a lot of different jobs in different company with networking, systems engineering, engineering, pretty much everything. I've been in this industry for over 20 years, so which tells you how old I am now. So yeah, very excited to be there and to be here and talk about all this stuff around network policy, security, zero trust, and BPF, eventually eBPF as in the roadmap. But yeah, so today is going to be mainly demos. I have a couple of introduction slides to introduce what we're doing at Authorize, why we are doing it, and then I have 3-4 demos. I'm not sure if everything's going to work, but it's live and it's no video or anything, so we'll see.
We promised up top we'll break things, so don't make me into a liar. I need you to break something. All right, are you ready for me to share your screen?
Yeah, I'm ready.
All right. I'm pretty new to tech, so I know just enough to ask a bunch of questions. So we'll do it.
Okay,
so even like helping. Yes, it's shared right now. Can you see it? Yeah.
I mean, I'm just seeing my presentation right now, so this is the only thing I'm seeing. So I don't have the live stream on. I can see, right? I just see my screen, and then I'll switch.
All I see is the presentation, right? Okay, I have your screen live, and it's just the presentation.
Yeah, that's good. So we can start. It's just starting with the presentation, a couple of slides. So here we just introduce myself. So what is this picture? I like to use this picture because, of course, Authorize. So why we are called Authorize is because we are saving authors as a living. No, I'm joking. It's the way Hebrew people pronounce authorize. It's kind of sounds like authorize. So therefore, the company was named Authorize. Right, which is good because it gives us like a very nice logo because everyone loves Otter as well. And so, yeah, of course, it's a security company based in Israel, as any good security company, I would assume. Checkpoint, I think CyberArk are also there. A lot of Aqua Security, all those successful companies. And today we're going to follow Otis the otter. This is kind of our mascot. And he's a developer, and he's making that particular face because he has to manage a lot of complex configuration when the security team, ask him to apply zero trust principle to everything. So to his code, to his deployment, to his Kubernetes configuration. But obviously, as developers, we use many different services. Can be Kubernetes, just deployment and other services, things like that, and pods. But also we can consume things like serverless services from AWS, can be DynamoDB or other databases. And of course, this, if you need to configure zero trust, which means essentially that any unauthorized or unauthenticated access is not allowed, you need to basically assume, start with a default denial for pretty much everything, and then gradually, with the least privilege sort of principle, have to kind of punch into Kubernetes, like punch in some ports, open ports, and also authorize specific user roles and permissions. Can be like IAM roles in AWS or in any other cloud. So, the challenge is that you need to understand all those components. So you need to understand IAM roles in AWS, permissions. You need to understand the same thing in Kubernetes. You need to understand network policies. If you're using Istio, you need to understand Istio authorization policies. Same thing with Linkerd. What else? You may have to manage Kafka or local databases, Postgres, SQL, and like Google service account, all those different disjoint security domains. You have to know how to configure them as a developer, because if you solely rely on the security team or on the platform team, this will lead to a couple of issues. First one is that typically you would have to use Jira, which means that instead of developing, you're going to be waiting for others to validate your accesses, and it's going to create lag between the moment between if you're in the middle of a sprint and you need access to a particular database somewhere to code or for your test environment. Well, you can't just afford waiting 3 days for the Jira ticket to happen. And most of the time, even if you have like a developer portal where you can provision some workloads, it doesn't necessarily include all the low-level security policies, right? Like networking policy, Istio authorization policies, all of that, certification, cert manager, or maybe like a workload identity with SVID from SPIFFE, for example, right? So there's a lot of moving parts here, and it takes time to do. And the idea at Authorize is, okay, let's offload this from the developer by creating a higher level abstraction so that it can just declare what he wants. If he wants an access to Kubernetes service, just specify it in your what we call a client intent. So we're going to go through that. And the idea is for the lower level domains, security domains, to be automated depending on what you want to secure. Is it an AWS workload? Is it a Kubernetes workload? Is it an internet intent? Is it a database hosted in Kubernetes? Depending on that, then we will apply the right security configuration. So it's sort of make life easier for multiple personas, for the developers, because now they have suddenly an easy way to declare their intents without having to figure out the low-level details. But also for the security team, because now the security is always up to date with the security team requirements. So if we say, okay, we want to have zero trust, meaning like everything is denied by default, that's the default configuration. And for any new service that the developers will create, it will be continuous. It will be adapted as soon as the developer creates push the code. They can at the same time push the client intent configuration and then just synchronize the desired state with the current state in Kubernetes using GitOps fashion. So of course we're using everything is based of Kubernetes custom resources. Client intent itself is going to be a custom resource that we're going to manage. And because of that, we can also leverage all the benefits of Kubernetes, like reconciliation, all these GitOps, all those sort of things. So at high level,
So,
this, yep.
oh, this is so. I just want to summarize what you said to make sure I understand. So we have people. You said the developer, but it sounds like maybe workloads also that need access to stuff, and that stuff could be all kinds of things. And
Yeah.
so we're talking about access policy and how difficult that can be to write, and how we don't have to wait for permissions. Um, how does how does the identity, how does the either the workload or the human have identity to be able to act to write the
Yeah.
policy?
Identity with, so today I will be more focusing on the security part, so the authorization.
Okay.
For the
Okay.
identity, we have an default integration with Cert
Uh-huh.
Manager, with
Okay.
Spire and Spiffy, and then it's
Okay.
just via the normal so service account that is mapped to a particular certificate, and we will
Uh-huh.
allocate the certificate to the pods just by using annotation. So as
Cool.
everything in Kubernetes is based off annotation, we do exactly the same thing. So to do all the intelligent stuff, we're going to be annotating a lot of different entities and objects in Kubernetes. So typically a pod, you will have the service account, and then you will have extra annotation to map it to a particular certificate. And then we can reuse, because we have this mapping now, we know which pod, which certificate is mapped to which pod. For example, we can do smart stuff with Kafka ACLs by completing, in the ACL, adding the common name from the certificate that is matching the particular pod, right? So we can do, there is different hooking point where we can automate the identity itself with the particular permission, with the authorization. So on the
Cool.
identity side, we have integration, actually three different ways. You can do it with, you can manage workload identity using Cert Manager, using Spiffy, or using our cloud solution. We also have, like, I'm going to show it a bit later, but our solution can also be kind of showed in the cloud just as a front end. Nothing is everything is open source, right? But it's just
Mm-hmm.
that for certain visibility and certain workflow, we can do it directly from our cloud. That includes, if you want to manage certificate directly from our cloud, you can do it as well. So that's the three different way to do it: Spire, Spiffy, Cert Manager, or via Authorized Cloud. That's really the first aspect, which is giving an identity to your workloads. And if you do it with, for example, Istio, we're going to see in one of the demo I've got, we're going to see how to automate the authorization policies. We're going to set the principles to the service account that is configured within the pod, right? So also, this is something that sometimes people forget to do, is for every pod, don't use the default service account. Always create a service account per deployment, or per type of service you want to deploy in Kubernetes. Otherwise, that doesn't make a lot of sense, because all the certificate, will be tied to this. Multiple pods, we have the same certificate, which destroy the purpose of having, workload identity. So it's very important to always check the service account first. So this is typically how you identify, like a pod will be via the service account, especially when we're going to show how to automate roles, IAM roles in AWS, right? Because this is how IRSA, I don't know if people are familiar with IRSA, which stands for IAM role for service account, which is how you can map a service account in Kubernetes into IAM roles and permission into AWS. And we're going to see how we can also automate this with Authorize, because manually there's a lot of moving parts. But yeah,
So,
so the idea is it's called IBAC, right? The process of doing all of that, of creating client intent, configuring that, is called IBAC, for intent-based access control. So here, I'll just give a quick example. We're going to go through that example in more detail. So here, imagine that I'm a developer. I've created a service that is called Joke Worker, and like that joke generator, which is part of a bigger application. And then I need to do different things. I need to talk to Nats to pick up the message to generate, please generate a joke. I need to pick up that message, so access to Nats. Then I need to connect to OpenAI API to generate my joke, store it in DynamoDB, in AWS, and also store it in the cache in Redis. It's a lot for that joke, but it's just for showing the purpose, right? For the purpose of showing that example. So here the client intent, as I said earlier, is just a custom resource where you specify the service you are calling from, like the client. So this is joke worker. I want to call NATS, right? So NATS is a service in Kubernetes. So the way we know what you mean by NATS is because we're gonna annotate all the pods, and that correspond to a particular higher level controller. So if your deployment is called NATS, then we will check all the pods, annotate all the pods with that particular service name, and then bubble up until the up to the deployment. So again, it's via annotation. We annotate every single pod in the environment, and then we bubble up until we find the particular service name. When I say service, it's not a Kubernetes service. It's the higher level controller. So it can be sometimes a service, but can be a deployment, can be a daemon set, can be whatever you want. Then same thing with Redis. I just specify, okay, I want to access to Redis. And if I need to access something on the internet, this is where it becomes also kind of interesting, because I can specify DNS name, and those DNS name, we're going to see it later, will be converted into IP blocks for network policies. So they will be constantly updated. So you don't need a specific CNI, like let's say a custom, like Cilium or Calico. They implement sort of specific custom network policies so that you can use DNS names. But here it's a bit different, where we're going to constantly update and kind of resolve from the DNS name to IP blocks. So you don't have to, you can use just standard network policies. And the type would be internet in that case. This is essentially to access external entities via DNS on the internet. And this is how we can specify in AWS you want to access a particular resource, as well as the permissions you need. So here, the particular resource I want to access, or the service again, is the ARN of a DynamoDB table. That's the jokes table. And because I need to both read and and write to that particular table, I just specify it's like a wildcard on the AWS policies, right? So this is how the different policies, permission policies, are going to be automatically created in AWS, because we specify the type AWS. Of course, we support different cloud as well. We're going to see for Istio is going to be type HTTP. And this is how we can integrate with the lower level, like security domains. But again, the idea is to make it super easy for developers. Even if they don't know what the application is actually accessing, we're going to see that using BPF this time. So maybe other stuff maybe later when we need it. But at the moment, we're going to see we have a sort of sniffer running on every node that is going to map traffic for every application. So we're going to see that these policies can actually be generated automatically for you. Not everything, like for AWS, I'm not going to show it today, but we are using another open source project that we have baked into our solution, which is called IAM Live. And IAM Live is an API proxy that allows the Kubernetes admin to monitor what API calls are made to the AWS API. So if you have an application, let's say in a kind of discovery mode, then we're gonna watch what calls this application is making, and then we can derive and calculate the permission that are required, and then we can just populate this particular client intents for you. So it's basically doing not only like the format, the client intent as a simple YAML, human readable file, but also we can generate them.
So I'm the developer. I just like to summarize. I'm the developer, and I am making that joke worker, and I know I'm going to need to access all those things. So I make one declarative resource, and then I list out all the different things that I need access to. Yeah.
Yeah.
Okay. Cool.
Yeah. That's basically it. So that was for we're going to see that in the second demo, which is a bit more complicated because there are more than network policies. But for the first demo, I wanted to show like the Docker, famous voting app where I've just added an ingress, a traffic ingress on top. But essentially, it's pretty easy. You have a vote in a result service where actually it's there on the left. Here you can vote for cats or dogs. And if I vote for dogs, normally I should see it's changing, right? So there's Redis DB worker. And let's assume that I've deployed that, but I don't know. Here, like that, this diagram, actually I did it using the net. So the component that we are using for mapping things out is called a network mapper. And this is the picture from the network mapper, because the picture on the Docker website is actually wrong, because it says from Redis to worker. Here we see it's worker to Redis, but there's just an arrow that is wrong on the website on that repo, which is Redis. It's going to worker, but it's the opposite. So let's take a look now. I'm just connecting to the cluster. Here we go. So first, in terms of the whole cluster, so this is a GKE cluster. So there's a lot of things moving part, like metric server, all that. It's a bit more than what you would expect. But here I've got my voting app. I've got 2 result pod, but that doesn't really matter. I've got 1 vote, 1 worker, Redis and DB. And you have the authorize, namespace where I've installed the solution. So the solution itself is just, I think it's still in memory here. If I do, Elm add Elm repo update, and then Elm just install authorize, and that's basically it. So very easy to install, 1 command. And then we have 3 main components. We have the credential operator, the intent operator, and the network mapper. The intent operator is the one responsible for translating the client intent high-level abstraction into lower-level security policies and configurations. The credentials operator is engaged every time we need to set username, password, or external permissions and roles, like AWS IAM, like PostgreSQL, Kafka, for example, all those kind of more specific credentials, workflows. They are managed via the credentials operator, and then the network mapper, which is basically talking to the sniffer. So here I've got a 2-node cluster GKE. Therefore, because it's a daemon set, I have 2 sniffer. The network mapper kind of aggregating all those discoveries, and then client intent, so the intent operator and the credentials operator. And the way you can interact, so the first thing, once you've deployed the application, I don't have any client intent right now, I'm just checking, and I don't have any default deny or anything. So I can start monitoring my application, and I can use the authorized CLI. So the authorized CLI is basically interacting with the network mapper. Just go back to the pods here and namespace voting app. So the first thing I can do is generate a PNG file. There you go. And then I can just open that. And you can see here that you have the application that is described, right? So it supports multiple namespace, because like here you can see .default means it's the default namespace. The .voting app namespace means, okay, the application or the component is residing into that particular namespace. And of course, if you want to be a bit more, have more information, you can go on Authorized Cloud. That will give you, so you can just register your cluster to Authorized Cloud. I mean, it's free unless you want support, of course. And you will have a bit more information. So here, what it's telling you is that if we are assuming default policy, and because I don't have any client intent configured, anything in red, any traffic in red would be blocked. So our goal now is to make it green. So for that, what we can do is use the same command again. So authorize network mapper, but instead of visualize, we can use export. um, voting app, and from the default namespace, right? Because we have traffic in the default namespace, we can just export everything. And I'm not going to apply it directly, kubectl apply, but just to show you, it's going to generate a bunch of YAML files. So it's going to generate all the client intent for you. And then I can just pipe this into kubectl apply, and then we're going to inspect what it's doing. So in terms of the network policies as well, I don't have any network policies configured yet. So what I can do is do that. So I'm going to just create all the client intent. And you can see now network policies were automatically generated as well. So if I go to the client intent, I have now 4 client intent. So for example, and you see on the left, it's green now. From result to DB, from result to DB, that's the result client intent. It says that DB needs to access results. Which one is a bit more? So worker needs to access both DB and Redis, right? So I can see DB and Redis. As easy as that, right? And I've got, if I now take a look at the network policies, you can see that because of the traffic requirements, I've got open up to XML to access, to vote to results, and also the other ones like network policies. If we take, for example, the Redis, we're going to see how we actually label everything. So now everything is kind of customized with the label that we apply. So from namespace selector, so this is the namespace, and then the label that we map to that is this one, intents.authorize.com, access Redis voting app with the particular pod, like a kind of suffix, equal true. So, and of course, now if we take a look at the particular pod, the Redis pod, and let's switch to the voting app namespace. If I want to access Redis, you're going to see that, of course, now it does have a new label that is intents.authorize.com service with that particular, label. So now for every pod that, so that's how it's labeled. And now for every pod that needs to access, we can just match that particular label, right? As easy as that. So we are effectively labeling every pod and then use extra label in the policies to explicitly say what can access what in the entire cluster.
Cool. What does it work if workloads are running in other clusters? Like, how does it work with multi-cluster?
Yeah, so for multi-cluster, we recently included support for multi-cluster, but for now it's for visibility only. So for example, here, if I removed my filter, I can see different cluster, but I don't have like an example here, but we can see cluster that are talking together.
Mm-hmm.
And we would see like a link between one cluster to another, even if authorize is not installed. So we can map other cluster as entities as soon as you have an ingress. That's basically the condition. As soon as you have an ingress, then we'll be able to map the communication between different cluster. And in the next step, it's basically support those policies between clusters themselves, right? But at the moment, visibility, and just later on this year is going to be between clusters.
Cool. Do you support Gateway API or intend to?
So today the only thing we do with ingress is allowing access from ingress to the ingress. We map the ingress configuration. Today we don't support gateway APIs, but it's going to come soon. As soon as someone asks for it, it's going to be.
Right on.
But I don't think a lot of people have already migrated everything to gateway API. But yeah, that's in the plan, of course. Oh, you're breaking up.
Uh-oh.
Oh, yeah.
Am I?
I can hear you again.
Okay.
Yeah, you're back.
Great. This is really cool.
Yeah, so this is for network policy. So now if I want, I can just apply the default deny, which I didn't, and then job basically is done, right? So now the next thing I wanted to show was the example with EKS. So I want to get to my EKS demo. Here you go, and this would be this part here on the top. Where we have actually the joke application. I'm just going to show you quickly, go back to the slide to show you what you would have to do if you were to do it manually, right? So that's the application on the lower end here. So typically how IRSA work, you need to go in AWS, create permission specific role with permissions. So in our case, if you want to allow a particular service account representing the joke worker, the joke worker is the component that needs to access DynamoDB, right? So you need to create a role for the joke worker so that it can do so. So first, you need the permission, which is allow DynamoDB and the particular resource. So don't put a start into the resource. I just did it because I didn't have enough space, but it should be the particular jokes table, the one I've showed before. Then you need to create a trust relationship, which include creating the OIDC provider for the EKS cluster. And then you need to populate the different, JOD configuration, so the JWT or JOD configuration for STS. So those different fields for the audience, the subject. Then you need to go to Kubernetes, and you need to annotate the service account, as well as, you need to allocate the service account with the particular ARN of the role you previously created. And you need then to map the different pods, or the deployment to that particular service account, right? So it's as a developer, you don't want to mess up with this. And if you have multiple service from Kubernetes, maybe, today it's DynamoDB, maybe you're going to be using another service in Google Cloud or in Microsoft, right? So it's a bit annoying, right? So here, and we can like same thing. We can map this out with extra network policies, right? So what we want to do is, again, have zero trust approach, where we want to create network policies with a default deny, as well as enable default deny for egress policies. So which mean like blocking the internet from the Kubernetes cluster, which, to be honest, like talking to users and like Kubernetes users in general, or people in the community, blocking egress is not necessarily the thing people do in production, but they should, right? Because you start with zero trust, the first thing you want to do is kind of filter external access from your Kubernetes cluster. So at least to limit, to do damage control, like the blast radius. If something is compromised, you cannot reach back, like the attacker or the bad actor sort of, environment, or like any other service on the internet. But for that, you need to have all this IP block. If you're accessing like DNS names, you need to convert that. You eventually need to do it manually. And if you have load balancers in between, like the IP address may change over time. So you have to maintain that, which is quite difficult to do. And this is why a lot of the solutions like, Cilium and, Tigera with Calico, they propose some egress or Istio. Usually you go through an egress gateway for that, which also can, add an extra level of complexity. So now the question is, how can we do it with client intent, which would solve a lot of the issues, right? So I'm going to just connect to my other cluster. Hopefully this one, I think, should be working automatically. Oops. Okay. So this is the same kind of environment. This is where I have my four pods. So I've got joke server, joke worker, Nats, and Redis. If I look at the client intent, this time I've already deployed them. And yeah, so the good thing with the client intent is that you can, once you have kind of discover what you have in the application, then you can store them, you can color code them with your code, so that when you deploy your application, those intents are deployed at the same time. So this is exactly what I've done here, because I've got my intent defined as part of, I'm using dev space actually to deploy that application. I just have an extra couple of manifests that contain my client intent here. And if we take a look at what I have here, exactly what I've mentioned before, in the slides. So for my worker, I want to call Nat Redis. I want to call OpenAI API. And again, I didn't know about this. It's just like going there. If I go to my AWS resource, internet, where's internet? Internet resource, internet here, I can see like live what the application is trying to access. So if I go then into my internet client intent configuration, I've got it defined for me, like authorized cloud. If you want as well, you can just check here what is the client intent, copy paste, and then you have exactly the right client intent with the right DNS calls. And now for AWS, it's just that because I've added this particular set of line, the resource I want to add, so the system has added this particular resource as well. But for the intent, yeah, we can detect dynamically what DNS name the application is trying to access, and then you can just add it here under the internet domain. And now, if you go to at the end of the intent, this is where the magic happens. So our network mapper, so here we are in the client intent custom resource. In the status properties, the network mapper is going to add constantly on a regular basis. I think it's a couple of seconds, like 10 or 8 seconds, is going to resolve the DNS name with the current IP address. And this is why now, if I go into the network policy view, so again, now client intent, they have automated the network policies. You can see like for the joke worker, if I edit this, I can see if I just go to IP block, I can see those IP blocks now. So those client intents are first translated into IP blocks here, but better in AWS now, if you go to IAM, so users, and you can check I think that's dev something, role, sorry. The role that has been automatically created is this one. So it has if you look at the client intent again, joke worker, it does have these permissions here, right? So this is the ARN, and this is the permissions here, right? This is exactly that. And then if you go into the trust relationship, it's been configured for you, right? And the only thing you have to do as a user is go to the joke worker pod, right? Because now is how do we map this? What does actually trigger that? If you go to pods and to the joke worker, you're going to see a label here that is involving the credentials operator this time. So we can say for that particular pod, actually I've set it up at the deployment level, but obviously all the pods is going to inherit the deployment template. So create the AWS role for that particular pod, right? And then because of that, we are creating this role and mapping out to the particular service account. So now if we go to the service account as well, I think I'm using the default. You shouldn't do that. I shouldn't have showed this. But basically, the credentials this was created by us. This was labeled by us, essentially. So we are automating the IRSA process as well. So now we have added an extra component on top of the network policies. So actually 2 components. We have enabled egress policies. So now we can create a default deny for both ingress, and egress, as well as use a serverless service like DynamoDB. And for example, now let's check if our application is working. So, sorry, I need to quit this. pods. So joke server, I just need to forward that port. And normally if just a loop, so I'm just redirecting this to my localhost 8080 and should be working, maybe not. Should be. Okay, that's the thing, demo doesn't work.
We
We've
promise.
this before. I may have forgotten to do something. Let's check. I'm not sure which one, but I'm sure the DB is populated. I've run it before. It was working. You have to trust me on that one. But
I do trust you. I deeply trust
uh,
you.
DynamoDB, I just want to check that I've actually written in the database. So here we have table. The jokes table is there, so it's been created, which is good. And explore table. Yeah, so I've got all my jokes that have been. I'm not sure why I don't have access to the joke server, something else maybe. But yeah, this is what I've run before, which means that my joke worker is actually accessing the DynamoDB database with the permission I give it, right? So I didn't have to call anyone. I just had to basically apply the client intent as long as I've got the right access to create those roles. So obviously, as a prereq, we need to tell the system, so the authorized operator needs to have the right access to AWS. So basically, the permissions to create new roles for that, right? So you need this extra kind of automation permission. But like any infrastructure as code, automation for the system, you need these extra permissions to be able to create roles and to create permissions for other users to act on behalf of them. Right? That's the basically the idea of that.
So, can you speak to, at a high level, you showed a slide of all the complexity involved that a developer has to go through. Can you speak at a high level to what the developer is doing now? Is it just making that intent object? It seems
Yep.
like there's maybe some tweaking involved before the zero trust
Yeah.
hits
So
the
basically,
default deny.
yeah, sure. So the workflow was exactly that, right? So create essentially the different client intent there, right? So I have
Uh-huh.
the four of them. So you can generate them using again the network mapper and add
Mm-hmm.
and add on top of that IAM live if you want to also monitor the API calls to AWS. I didn't use that because I knew which resource I needed to access, right? So it's basically
Mm-hmm.
using the information from the network mapper, also using the information from AWS, which what resource you need, and then it's just mapping the deployment, like in the deployment template within your. So if I go deployment here in the worker, it's just doing this, like this annotation. Where is it?
Mm-hmm.
This label. Where is it? In the template. Sorry, in the pod template. This credentials operator authorize.com create AWS role true. As soon as you do that, because we know which pod you want to or which deployment you want to authorize, and grant permissions to AWS, we will then do all the annotation for the service account because the service account is also attached there, right? So
Mm-hmm.
we're going to do the IRSA automation for you. So if you have an EKS cluster, with the OIDC provider, right? That's the only thing, because to get you need like to match the prereq of IRSA because we are automating IRSA, and the prereq of IRSA is you need to have an OIDC provider for your EKS cluster. That's one. You need the EKS cluster, of course. That's two, and then
Mm-hmm.
you need to have the three operator install, the client intent created, and then once you have the foundation, one label, and it's working. So
Nice.
before we had all those, JSON from like to configure in AWS, all the different labels to do on the service account and map the service account to IRSA, all that. Here we just have one single label to do. That's essential.
Cool.
And the
I have
last,
more.
yep, sure.
More questions. You said you've been saying a couple of times apply a default deny. Is a default deny a resource that's available as part of authorize? What's a default
No,
deny
actually, the default
exactly?
deny. So here, for example, let me check. Look at this, that joke, that's the policies. Here, like the default deny that you would apply is a network policy. It's not like authorize. Here we can do like assume default deny would be assume, like, but we don't apply it for you because it would be too disruptive. So I
Yeah.
didn't mention it, but there's a, in a brownfield environment, actually, let me show you this. In a brownfield environment, you wouldn't default deny first. You would do pretty much what I've done here. But if you look at our CRDs, if you filter by authorize, we have a couple of them. Of course, I mentioned we can configure Kafka, MySQL, Postgres. We have a protected service. So by default, when you install authorize, there are two modes, like enforcement active or shadow mode. In shadow mode, we're not going to generate the network policies, right? So you can gradually, but still, you can still generate the client intent, but the client intent won't lead to network policies. But then what you do service by service, when I say service, it's not a Kubernetes service. It's like, can be a deployment, like at a, like a higher level type of service. Then you can create a protected service. And when you create a protected service, it's going to kind of enforce the policies, but just for that particular set of pods instead of the whole namespace with a default deny, right? So the idea, if you're in a brownfield environment, instead of using authorize in enforcement, you just use it in kind of shadow mode. And then service by service, you switch like the button into, I'm going to create a protected service and check that, of course, assume default deny is green, right? And once you have gone through every single service in your namespace, then you can just apply the default deny, but it's not like an authorize component. It's just like, if I display that, it's just a network policies default deny.
Okay.
If you were using Istio, you would use an authorization, a default deny authorization policy as well, right? That's
Got it.
what you would do. But if you're starting from a blank sheet, then you can just enforce from the beginning, and then because it's nothing is there, when you have your client intent, you can just tinker with it, and normally it should be fine. And yeah, so actually that's another thing I want to show you is the authorization policy. So here, for example, I need to switch my context to Istio. So this one is going to be, Minikube. It's going to be just local. So same thing, I think it's install. Yeah, it's everything has been deployed. I just want to show you the mapper and the client intent. Istio pods here. So I just have one namespace with the online shop. And if I here authorize network mapper, export online shop, you can see because I've configured Istio with authorize. When I've installed it, I've just specified, like it's going to be using HTTP, calls. Then automatically the system is aware that I'm going to go above layer 3. So now I'm going to go to layer 7, right? So by looking at the Envoy proxy. So if you have Envoy proxies installed in the namespace where you apply authorized network mapper export, then by default, we're going to go into Envoy and pull Envoy metrics so that we can understand what calls are actually made. And now we have a new type. Instead of being just call and the name, we have type HTTP. And again, we can just apply this to Kubernetes. And I should see new client intent. And I should see, as a result, I should see also, if I go to CRDs, authorization policies. So I'm not making this up. It was 15 seconds ago, right? So it's created, although it's also required authorization policy with the path, the method, and the principles as well that we derive from the service account, like the identity. Again, we are using, labeling the different entities to make our picture of the application. to make the map of the application. So this one is actually next level. Is now, a lot of people who are using service meshes are using it for only MTLS. So if you have already Cert Manager or a Spire server, first of all, Authorize can just automate that, and you don't need a service mesh at all. But if you also want to manage authorization policy, whether it's Linkerd or Istio today, we can generate the authorization policies. We don't manage like the request authentication. So I'm really talking about the. Actually, I've got here the diagram, I believe, maybe, or I don't have it. No, I don't have it. That was the diagram that shows the application. But basically, it's I can actually show that. If I, again, instead of authorize network mapper, we can do visualize. And that's what's the name of the namespace that was online shop. Now open up. Yeah, so that's my that's what my fake or online shop is looking. Like we have the front end talking to the cart, order, and products. That's basically it. Very simple. But yeah, so as soon as you've got this application installed, now you can use the mapper to map your application at layer 7. Let's at layer 7. And if you look at the pods, yeah, you can see those 3 pods are just the 4 pods are in the online shop namespace. Right. So I've demonstrated. So network policy is ingress plus egress with DNS. Now I've also showed Istio. 5 minutes. I don't have time, but I had another one, but you will have to believe me on that one. But we have integration with, if you go into our integration here, with GitHub. So what is essentially doing, and this is where, if people are interested, you can go on this page, on the tutorial, authorized tutorials. We have GitHub and to automate authorization pull requests. So what it's going to do? So the first time you deploy this online shop application, you're going to have the client intent generated day one, right? So you have the repository with the client intent into an intent directory within that repo. And day 2 or second week, you are adding a new service to your application, new sprint, new service, or you're changing the access pattern. So if the network mapper detects new pattern, it can do pull request on behalf of the developer on the repository with the delta. So if we detect a new access, then we'll generate the new client intent and create a pull request with that content on the repo. And then the platform team or the developer or the security admin or whoever validates the new access patterns can just merge that particular pull request. So that's the more like integrating into different workflow and CI/CD pipelines as a result of that. That's basically the last part.
What
I
if
wanted to show.
in the client's intents, can there be conditionals? What if you only need to access the database if the person's over 65 or something?
Yeah. So the conditions, so for example, especially like in AWS, you can add conditions to the different policies. So it's very close on the roadmap because we had different users that wanted to do that. So this is going to be available very soon, and I think that's a great features to have because those conditions, not necessarily for network policy, you don't need condition, but you may need condition in Istio because you can add when keyword in Istio authorization policies, and you can add conditions as a key name into AWS. So this is going to come very soon as well.
Awesome.
So if people want to scan anything, I've got this QR code just that will lead to the tutorial. If anyone is interested, simplest way how you can get started, go to the tutorial. They are part of our release cycle, which means that the tutorials are managed by developers and are part of the test. So usually they are always working with the new features and updated almost in real time. And the second one, if you want to chat with me, or maybe if people, user may have different use cases or support something else, you can just join the Slack channel. I'll be more than happy to answer any questions. And I want to also insist on the fact that this is community driven for all the, the lower level security configurations, like the Linkerd support we have was created. Actually, was a pull request from a user. We have the framework,
Cool.
right? We have the unified policy framework that is already there. So we are just waiting for people to throw more use cases to make it more popular and much more, deployed everywhere. Because we think, managing security this way for developers and for platform admins and security teams can really save time for, just everyone's work.
So you said if people have questions to find you in the Slack channel, does Authorize have its own Slack channel, or are you talking about in the CNCF Slack workspace?
On both. People can find me. So this is like the Authorized community Slack channel that people can join. But I'm also on the CNCF Slack channel if people wants to directly connect with me as well. No problem.
Wonderful. Thanks everyone for being here. We have some nice comments. We have this is awesome, and thank you so much for today's presentation. Good job, Nick. Is there anything else you'd like to say in conclusion before I get into the ending script?
No, I think I was very happy to be here today. Not every demo works. I wasn't expected that everything to work because that's 3-4 different demos. But, yeah,
it makes it human, it makes what you do way more impressive.
Yeah, exactly. And I didn't have time for the last demo, but doesn't matter. If people want to have a chat, I'm going to be at the next KCD in Europe, so that will be KCD Munich. I don't know if you're going.
Oh, I'll be at KCD Munich. Yeah, I'll meet you there.
Cool. So I have a talk there too. So if people wants just to come by and say hi, just have a chat or whatever, I'll be there too.
Cool. I'll see you there, Nick. That's awesome. So thanks everyone for joining today's Cloud Native Live. It's great to have Nick Vermandy here teaching us about intent-based access control with BPF and traffic pattern detection. The audience is always great. Thanks everyone who said hello. And if you have any questions, feel free to put them in the comments of this video and we'll make sure Nick finds them. So thank you so much. Here at Cloud Native Live, we bring you the latest in Cloud Native code on Tuesdays and Wednesdays. So we're going to do this again tomorrow at the same time. And thanks for joining us today. And thank you, Nick, for sharing your time and expertise.
Yeah,
goodbye.
Thanks,